This is a triangle ABC of side 2 meter each. Here we have electric field E, which is 10 volt per meter. Find VA minus VB and VB minus VC. Now, in first case, VA minus VB we want. So change in V, its magnitude is E bar dot delta R bar. That is E delta R cos theta. Delta R means A to B distance. What is angle between A to B and E? This angle is how much?
60.
60 degree. So it will become E10, A to B distance 2, and acute angle between them is cos of 60. That means 20 into half, which is equals to 10. Now, A is greater or B is greater?
B.
B.
B. So that means this is VB minus VA is 10. Correct? Na?
Yes, sir.
Yes.
So VA minus VB will be minus 10. First part followed.
Yes, sir.
Second part, VB minus VC is equals to. Now V is greater, we can clearly see, minus VC. E is 10 into 2. What is angle? Is it 0? Between this?
Yes.
So 20. Okay, direct answer. Copy. Yes, done.
Yes.
Okay.
Yes.
Now, in this case, we were taking uniform field. Now, case 2, if electric field is not uniform, that means field is not same throughout, it is represented by this. Field is not uniform. So at point 1 and at point 2, field will be directed outward but not same in magnitude. But in very small distance, we can assume it to be constant. So here dV, which is minus of E bar dot dr bar, can be written as total change will be integration of dV from one point to another point. That is same as minus of E bar dot dr bar from R1 to R2. If field is not uniform, then we'll take integration. Copy.
Done, sir.
Okay. If E bar is given as Ex I cap Ey j cap plus Ez k cap and dr bar is equals to dx I cap plus dy j cap plus dz k cap. Then dv will be E bar dot dr bar in minus sign. That will become minus of Ex I cap plus Ey j cap plus Ez k cap, its dot with dx I cap plus dy j cap plus dz k cap. So this will become minus of Ex dx minus of Ey dy minus of Ez dz by dot product followed.
Yes, sir.
Yes, sir.
That means can I say Ex is minus of dv by dx and Ey, hello,
Yes, sir.
when you partially differentiate this, then dv with respect to dx will be only this much. Now this all will become 0. Similarly, Ey will be dv by dy and Ez is minus of dv upon dz. This is called partial differentiation. So if you differentiate this partially, then dv, which will become delta v, only first term with respect to x, with respect to y, with respect to z. Copy this much. So E bar is minus of derivative of v with respect to x I cap v with respect to y j cap, v with respect to z k cap. Magnitude will be root of ex square plus ey square plus ez square.
Done, sir.
Based on this, we are solving few sums. V is 2x minus y plus z. Find E bar at 1, 0, 1. Find also magnitude of E bar. Now B is given 2x minus y plus z. So E along x will be partial derivative of B with respect to x with negative sign. So this will become minus of derivative of this with respect to x. X 2x ka derivative 2. This is 0. This is 0. So we get answer minus 2. And Ey is derivative of v with respect to y negative sign. So minus of 2x is constant, so 0, minus 1 plus 0, so equals to 1. And Ez is v ka derivative with respect to z. So 2x is constant 0, y is 0, z ka derivative 1, therefore 1. Therefore E bar, see इसका कुछ यूज नहीं मिल पड़ा अपने को, because we got all constant. Hello?
Yes, sir.
Yes, sir.
So can I say E bar is minus 2i cap plus j cap plus k cap?
Sir, EZ minus
Sir,
1 होगा.
minus K cap, na?
No, minus 1. So minus k cap. And magnitude of E will be root of minus 2 square plus 1 square plus of minus 1 square. So that will become 2 square 4 plus 1 5 plus 1 6, root of 6. Clear?
Yes.
Try.
Done, sir.
V equals to x square y plus y square z. Find E at 1 comma 1 comma 1. Also find magnitude of E bar. Will you try this?
Yes,
Yes.
sir.
Just remember, when you are differentiating with x, x छोड़ के बाकी सब कांस्टेंट होता है. So E का डेरिवेटिव with respect to ये V with respect to x. So minus of इसमें y is constant. What is derivative of x square? 2x.
Yes.
And this whole thing is constant. Derivative of constant is 0. Hello?
Yes.
Now we want answer at 1 1 1. Correct? We want answer at 1 1 1. So if
Yes.
I put x ka value 1, y ka value 1, what I will get here?
minus
Minus
2.
2.
Minus 2. 1 into 2 into 1, that is equals to minus 2. Correct. Similarly, ey and ez, can you solve?
Yes,
Yes.
sir.
Try.
Sir, root 21.
Root 14 I am getting.
Yes, sir. I also got root 14.
I have solved. Please check those who have got bit mistake in the plus minus. Root 14. Aryan, check your mistake. You are able to find your mistake somewhere?
No, sir.
देखो क्या पहला क्या आया, ex क्या आया, -2 आया,
Ex minus 2. Yes, sir.
और ey -3 आया.
Ey minus 4.
नहीं, 3
minus.
आएगा ना, 2 into 1 into 1 ना, शायद उधर.
Yes, sir. Yes, sir. हाँ, समझा समझा. Okay.
Okay, rectify. Next one. V equal to x square y plus y square z plus z square x. Find E bar at 1 comma 0 comma 1 and magnitude of E bar. This one you try. At the end, I will reveal the answer.
Sir,
Yes.
sir, in EY minus and then bracket of x square, it should be 0.
Benefit of x square should be 0. Y derivative is 1 now. X square is constant. Derivative of y with respect to y is 1. Just check. I got ex as minus 1, ey as minus 1, ez as minus 2. What you all got? Yes, Jennifer?
Sir, I got EX and EZ right. EY I got wrong.
Just see, have I written correct? X square is constant as it is, y derivative 1, z is constant as it is, y square is 2y, z square x everything is constant, so 0.
Yes, sir.
So x square y is 1, that means I'm right, I think, minus 1.
Yes, sir. Root 6 is wrong.
So e bar you will get minus I cap minus j cap minus 2k cap, and magnitude of e bar will be root of minus 1 ka square plus of minus 1 ka square plus of minus 2 ka square. So 4 plus 1 plus 1 6, root of 6, correct?
Yes.
Root 6 na, correct na?
Yes.
Okay.
Yes, sir.
Yes, sir.
Next. E bar equals to x I cap minus 2y j cap plus z k cap. Find delta V between A having coordinate 0 to 4 and B having coordinate 2 1 0. See, ulta पूछा है. This time E is given, V we have to calculate. So delta V, that means change in potential is integration from A to B minus of E bar dot dr bar. Formula write down properly. पेपर डिफिकल्ट हो तो ऐसा उल्टा भी पूछ सकते हैं. You just complete till this, then I'm explaining further.
Done, sir.
Now dr bar you can assume as dx I cap plus dy j cap plus dz k cap. So this becomes minus of x I cap minus 2y j cap plus z k cap into dr, which is dx I cap plus dy j cap plus dz k cap. Dr means small change in x, y, z going from A to B. So minus of x dx dot product x dx minus 2y dy plus z dz हो गया. From A to B, A to B are coordinates given. A coordinate is 0 to 4 and B coordinate is 2 1 0. So this will be minus of integration of x is x square by 2 minus 2 y square by 2, z ka integration is z square by 2, limit of integration is given 0 to 4 2 1 0. Please copy till this. Space coming. X has 2, lower limit as 0 and upper limit as 2. X upper limit 2 square minus of 0 square upon 2. First term over. Second one minus upper limit 1 square minus of 2 square. Plus z square, which is 0 square minus 4 square upon 2. So this will be minus of 2 square 4. 4 upon 2 is 2. Minus 1 square is 1 minus 4 will be minus 3. 1 square is 1. 2 square is 4. Minus 3 minus minus plus 4. Minus 4 square 16 upon 2 is 8. This will become 2 plus 3 5. 5 minus 8 is minus 3 plus 3. Okay, done.
Yes, sir.
Yes, sir.
What is right? Electrostatic potentials due to charged sphere. We have done due to point charge, due to electric dipole, Now charged sphere. First one, case 1, potential due to hollow conducting or non-conducting or solid conducting, all are same. Only solid non-conducting is different, rest all are same. Solid non-conducting मतलब charge अंदर रहेगा, it won't come to the surface directly. Or solid conducting sphere of radius capital R at distance small r from center of sphere. Now r can be greater than capital, smaller than capital, equal to capital. First write this heading, then one by one we'll do all. Heading right, huh? Completed writing?
No, sir.
Done, sir.
First one, point lies outside. That means small r is greater than r. We have to derive expression for potential. So if this is sphere, given charge q, its radius is r, point P is outside. So what is formula for intensity at point P outside the charge sphere? K Q upon R square. Correct?
Yes.
We are interested in potential. So we know formula. Change in potential is EdR by integration. Because E is not uniform. At every distance it will keep on changing. So we have to integrate. Hello? So potential at P minus potential at infinity is total change in potential from infinity to R, correct? Hello?
Yes, sir.
E means here it should be E bar dot dr bar. Now what is potential at infinity? Is it 0?
Yes, sir.
Equals to now minus K Q upon R square dr into cos 0 by integration from infinity to R. चलो कर लो इतना. Potential difference is E bar dot dr bar का dot product. Potential difference means potential at P minus potential at infinity. That means we are taking the point from infinity to R. Potential difference between point from infinity to R is integration of E dr from infinity to R with opposite sign.
Done, sir.
So this will become Vp equals to minus k cube integration of r square goes up r raised to minus r dr from infinity to r, that is minus k cube r raised to minus 2 ka integration is minus 1 upon minus 1 from infinity to r. This will cancel. So it is k cube into 1 by r from infinity to r, that is k cube into 1 by r minus 1 upon infinity equals to k cube by r. Now if you see carefully, intensity was kq by r square and v we are getting kq by r, so indirectly it is v by r equals to e वाला आ गया ना. Hello.
Yes.
So what is potential at any point outside the charge sphere? Kq by r. At surface what it will be?
KQ by capital R.
Kq by capital R, correct. Yeah. Do. Can I rub this? So we got outside kq by r, on the surface kq by capital R. Now we have to check inside.
Sir. Hello, sir.
हाँ बोलो.
Sir, R 1 upon R square dot dr का इंटीग्रेशन log r the whole square नहीं हो सकता है?
नहीं नहीं, वो 1 upon x के
मतलब
लिए log of x है ना. जब
अच्छा,
तक
1 upon x square के लिए नहीं है वैसा?
नहीं नहीं, उसका पावर निगेटिव, इसका जीरो नहीं हो रहा है ना डिनोमिनेटर.
अच्छा, ठीक है.
वो कब क्यों नॉट डिफाइंड होता है ना, जब ये जीरो हो जाता है, तो इसलिए हम दूसरा कॉन्सेप्ट से जाते हैं.
ओके सर.
अभी पॉइंट इज सपोज इनसाइड, that is when r is less than r. So if this is sphere of radius capital R, point is somewhere inside at distance r from center. What is intensity at any point inside the charge sphere?
0.
Zero. So electric field inside at point P will be zero. But see, potential will prove it is not zero. Change in potential from the surface to the point P will be V P minus Vs. This will be equals to E bar dot dr bar moving from S to P in opposite. That will be minus of 0, है ना? E is 0, correct? Inside.
Yes.
So 0 into dr. Therefore Vp minus Vs will become 0. Hello?
Yes, sir.
Yes.
That will give you Vp equal to Vs. S मतलब surface पे. हेलो,
Yes, sir. समझा.
अभी देखो जस्ट इनसाइड सरफेस से लिया तो ई जीरो था ना, तो हम लोग ने जस्ट
Yes, sir.
इनसाइड द सरफेस वाला पॉइंट कंसीडर किया है, तो वीपी इक्वल टू वीएस हो गया. क्या आया? के क्यू बाई आर आ गया ना. मतलब फील्ड इज जीरो बट पोटेंशियल इज नॉट जीरो. आर यू गेटिंग द फॉर्मूला? वेरी इंपॉर्टेंट
Yes.
फॉर्मूला.
Yes, sir.
Solve it. We went from surface to inside. Just from surface to inside, E is 0. So we are getting Vp is same as V at the surface. And V at the surface we derived Kq by R.
Done, sir.
फिर एक नोट से करके लिख लो तीनों फॉर्मूला. फॉर चार्ज स्फीयर, first point lies outside, B is kq by r. Point on surface, B is kq by capital R. Point inside, r less than r, B is same kq by r.
Done, sir.
Graph of V versus distance. V versus distance. What is meaning of this origin? Where is point?
At the center.
Very good. So if V is on the center, what is potential? R is point is on the center. What is potential here? K
KQ by R.
by R. Then it remains constant to anywhere inside the
Yes, sir.
till R equal to R तक. Then it becomes inversely proportional outside. So this
Yes.
is graph for inside and this one is graph for outside. Exactly same अगर E versus R होगा तो inside 0 हो जाएगा till R equal to R तक. फिर ऐसा आएगा outside. And this on the surface it will become maximum, which is kq upon r square.
सर ER ग्राफ का स्लोप ज्यादा रहेगा ना, मतलब स्टीप रहेगा ना वो.
इसका हाँ
ER ग्राफ का
दोनों जब ये एक दूसरे के साथ कोइंसाइड करेंगे, स्क्वायर वाला नीचे आएगा और वी वाला थोड़ा ऊपर आएगा। हो गया ये ग्राफ में?
Yes, sir.
Next, potential due to solid non-conducting or sometimes they say dielectric sphere of radius capital R at distance small r from the center of sphere. So again we'll see three cases: inside, on the surface, outside. First you write heading, then one by one I am doing all the three. हो गया?
Yes, sir.
अभी चार्ज कहां पे रहेगा? ऑन द सरफेस के इनसाइड रहेगा?
Inside.
inside.
The point lies outside if r is greater than capital R, but our sphere is non-conducting, so charge will be uniformly distributed in the space inside the sphere. Radius of sphere is r, point P is outside at distance r. So total change in potential difference is integration of E dr bar from infinity to point P. Because from infinity we are coming to point P, here we want potential. So again Vp minus infinity will be minus of E ka formula is kq upon r square into dr into cos of 0 from infinity to P. Therefore we get Vp minus 0 is minus kq integration of r raised to minus 2 dr from infinity to r. So Vp is kq minus kq r raised to minus 1 upon minus 1 from infinity to r. Therefore Vp is kq into 1 by r from infinity to r. So Vp is kq 1 by r minus 1 upon infinity. Therefore Vp is kq by r. So if point is outside, then whether the sphere is conducting or not conducting, always formula will remain same, kq by r. First case copy. Point is outside, same formula we got as it was for hollow charge sphere. Okay, completed.
Yes, sir.
Yes, sir.
Okay. Inside sphere, R is less than capital R. What is formula for intensity at any point P inside the charge sphere? याद करो, याद आया क्या? K Q R upon R cube. याद है ये फॉर्मूला इनसाइड चार्ज स्फीयर? फिर समझा देता हूँ, फ्लक्स वाले से बताता हूँ, फ्लक्स से. If the point is inside the charge sphere, what will be the, by Gauss's theorem, what will be charge enclosed? See, if charge is rho, rho means charge per unit volume. So charge enclosed will be rho into 4 by 3 pi r cube, correct?
Yes.
Intensity at any point inside I am finding by Gauss's theorem. This is radius r, this is radius small r. So charge inside will be rho into 4 by 3 pi r cube, बराबर, अपॉन एप्सिलॉन नॉट. ठीक है, ये फ्लक्स हो
Yes.
गया ना इनसाइड. इन Q upon epsilon naught is, we want intensity at point P. So intensity E at any point is constant, which will be throughout this sphere. So here I will write 4 pi ये sphere लिया, ये Gaussian surface, so charge enclosed is equals to, flux equals to Q upon epsilon naught, which is same as E into dr bar का इंटीग्रेशन ओवर गॉसियन स्फीयर. यही था ना अपना फॉर्मूला. हेलो,
Yes, sir.
तो ये 4 पाई आर स्क्वायर आ जाएगा गॉसियन स्फीयर के लिए.
हाँ.
तो 4 पाई कैंसल, आर स्क्वायर का ये कैंसल आर, ई बिकम्स रो इंटू आर अपॉन 3 एप्सिलॉन नॉट, बराबर. बराबर हुआ ना इधर तक?
Yes,
Yes,
sir.
sir.
अभी रो को मुझे क्यू में लिखना है.
Q by V.
हाँ, तो it is nothing but Q. V is what? 4 by 3 pi capital R cube into R upon epsilon naught. अभी 4 pi epsilon 0 को 1 upon 4 pi epsilon 0 को नाम क्या दिया? K दिया ना. ये 3 cancel. So this becomes K capital Q into R upon R cube. अभी समझ गया आपको ये फॉर्मूला?
Yes, sir.
देखो, नहीं समझा तो फिर से एक बार बताता हूँ. जेनिफर, you have followed full?
Yes, sir.
Okay, Aniket, Tasmay.
Yes, sir.
Once again, see, we have got time. Again, I'm repeating. First, I'm finding what is intensity, because from intensity we'll get potential. So intensity at any point inside the charge sphere. So this is charge throughout. If you include Gaussian sphere, then charge inside will be equals to charge inside this, rho equals to charge upon volume. So charge will be rho into iska volume, which is 4 by 3 pi r cube upon epsilon naught is flux, but flux is nothing but E into small point dr का इंटीग्रेशन थ्रू आउट, तो इसलिए E इंटू 4πr² यही फ्लक्स है, रो इंटू 4/3πr³ अपॉन एप्सिलॉन नॉट, 4π कैन कैंसल and r² का r cancel, so in terms of rho we are getting rho r upon 3 epsilon naught. Now rho means charge upon volume, charge is q, volume is 4/3 pi r cube पूरा sphere का अंदर, into r upon 3 epsilon naught, 3 cancel, 1 upon 4 pi epsilon naught means k into q into r upon capital R cube. Okay, have you followed now?
Yes, sir.
Yes, sir.
So intensity at any point inside the sphere EP is equals to k q r upon r cube. So we want inside, S is the surface, P is point inside where we are interested in potential. So V S to P when you are moving the charge, this is minus of E dr S to P. S is just touching this. So it will become Vp minus Vs is minus E inside is K Q R upon R cube dr from S to P. So that will become Vp minus V on the surface. We know it is KQ by R will be equals to K constant, Q constant, R cube constant from surface to point, that means from center it was capital R up to any point R from this center. We brought R to any point P which is at distance R from the center. So R dr का इंटीग्रेशन इतना लिखो जरा. Simple.
Yes.
Everybody's fine.
Yes.
So this is like Vp minus Vq, Vp minus Kq by R equals to minus of Kq upon R cube inside. Integration of R will become R square by 2 from capital R to small r. So Vp minus Kq by R minus Kq upon R cube R square by 2 minus capital R square by 2. So Vp minus Kq by R will become minus into this minus will be Kq into R square upon 2 times R cube plus हो गया, और second term Kq R square upon 2 times capital R cube, ये R square cancel. So Vp will be, this I am bringing on this side, Vp equals to Kq by R plus Kq by 2R minus Kq R cube upon 2R cube. So Vp equals to, LCM will be 2R, this is 2 plus 1, 3 times Kq minus Kq R square upon 2R cube. So this equals to Kq, I am taking common, 2R I am capital R I am taking common. So inside we'll get 3 by 2 first term minus of R square. r square upon capital R square. 2 times capital R square. KQ by R 3 by 2 minus R square upon 3 times. देखो बहुत difficult है याद रखने के लिए. So 4-5 times you write and practice. एक बार derivation खाली practice कर लेना. So that in case you forget formula, you can derive in the exam. So we get Vp is KQ by R 3 by 2 minus R square upon 2R square. This is formula for V at any point inside the non-conducting charge sphere. Solve this much. KQ by R 3 by 2 minus R square upon 2 capital R square. At least 10 times when you write, you will remember, otherwise you will forget.
सर यहाँ पे VP माइनस KQ बाय R क्यों किया? VP माइनस V इन्फिनिटी क्यों नहीं किया?
नहीं, मुक्त ने कहां से मूव किया? सरफेस से मूव किया ना, इधर से मूव किया ना,
ओके,
सरफेस से
हाँ
अंदर.
चलो.
इन्फिनिटी से मूव करेंगे तो ये स्टॉप करेगा ना उसको, तो सरफेस से अंदर लेके देखा क्या हुआ.
Done, sir.
So indirectly we can say V at any point inside is proportional to minus small r square. Now at center r is 0. So V at center will be KQ by R 3 by 2 minus 0 square upon 2R square. See, if it is solid conducting sphere or hollow sphere, then at the center and on the surface potential was same. If it is non-conducting solid sphere, at the center we are getting 3 by 2 KQ by R. Therefore, V at center is 3 by 2. This is V at the surface. So V at center upon V at surface is 3 by 2. So center wala is always greater than that of the surface. So sometimes this type of theoretical they can say. In case of solid non-conducting sphere, potential at center is how many times that of sphere? It is 3 by 2 times. Very difficult paper, then this relations will come. You have to be alert from every side. Can I clear this?
Done, sir.
Okay, अब इसका ग्राफ देख लो आप, फिर स्टॉप करते हैं आज। और वापस आप खुद भी रिवाइज करना, नहीं कुछ समझा तो मुझे पूछना। आई एम डूइंग ईच एंड एवरीथिंग एज पर एनसीईआरटी। दिस इज डिस्टेंस r. If point is on the center, then v at center we got maximum, that is 3/2 v at surface, है ना? हेलो?
Yes, sir.
So ये r equal to r मतलब किधर आ जाएगा? सरफेस पे आएगा ना?
Yes, sir.
सरफेस पे इट इज, ये सपोज v at सरफेस, तो ये वाला v at सेंटर, लेकिन ये कर्व इसलिए ऐसा आया बिकॉज इट इज ऐसा ऐसा हो जाएगा। हेलो?
Yes, sir.
इधर तक समझा आपको? सेंटर पे r इक्वल
हाँ
टू
सर।
कैपिटल R, सरफेस पे अगर 9 है तो इधर होएगा 3/2 टाइम्स 9, तो इधर ऊपर दिखाया मैंने, लेकिन इनवर्सली प्रोपोर्शनल इससे ऐसा दिखा दिया डाउनवर्ड, कर्व में डाउन होएगा, ऐसा नहीं दिखाया क्योंकि नेगेटिव था उसका r। देखो vp इज प्रोपोर्शनल टू माइनस में आया था ना, तो प्लस में रहेगा तो ऐसा दिखाना है, माइनस में तो मुझे उल्टा दिखाना है, ये मीनिंग है। तो ये हो गया v सरफेस, then it is inversely proportional to 1/r outside. So this is the graph drawn out.
Done, sir.
So that's all for today. Potential we have completed. Then shell वाला एक बाकी रह गया, two concentric shell. What will be potential at center and what will be the induction of charges? So one more lecture will be taken. Then electrostatic completed full.
Sir, tomorrow test, na?
Tomorrow is test as I have given. And Saturday when I take the lecture, first I will clear the doubts of Aryan which he has sent. Aryan, now you'll be able to understand because so many theory we have done.
Yes, sir.
So that's all for today. Tomorrow test. Everybody has sent the paper, those who are attending lecture today.
Yes, sir.
Yes, sir.